Okay, this is the second half of the lecture. This is going to be the 2.3 portion. Here are the answers to our worksheet. Okay, I'm giving you a little bit of time to go over those and check your answers and make sure you got the right answer. If not, you can come into class and ask. Okay, moving on. Pause it if you need to. Oh goodness, I did not erase. I was doing a little bit of a practice run, but I'd erased them all. I guess not. Okay, hang on. Let me get the screen erased. I'll explain all this writing and redo it for you. All right. Yeah, it looks like none of the rest. I think that's all the further I practiced. All right. Now we're talking about the transformations of polynomials, and I'm going to make you seasick by rolling it back and forth like that. All right. Why? This is a standard equation for a polynomial. What does it look like? I know it looks awful. Okay, but only just so that it can be very, very generalized. We have no idea how many terms. We don't know what the terms are. We don't get the idea. So, all right. The leading coefficient is a sub n. That's my leading coefficient. Actually, plus x to 0, so we have a sub. That would be my trailing coefficient. All right, we're mainly going to be looking at our leading coefficient. Direction, if A, our leading coefficient, is greater than 0, and the degree is even, it opens up. The degree is odd, it's going to have a positive directionality. What I mean by that, I'll show you in a minute, because the second one is if it's less than 0, then it opens downward or in a negative direction. The thing is, depending on the degree, tells me a lot of things. Okay, so if it's an even degree, it's like a polynomial. Sorry, no, it's like a quadratic, which is x squared. A q squared to x to the fourth would look something like that. X to the fifth. Now these would be positive. Okay, but see, I'm just increasing the number of bumps and squiggles. So, but notice for a positive even degree, it's going to open upwards overall. For a negative, it's going to open downwards, okay? Like your parabola does. But the difference comes when I have an odd degree, I will not have, they won't be going in the same direction. So what happens, if I have a x cubed positive looks like this, and notice, overall, if you put a point where it comes into your window and out of your window, overall the slope would be positive. Whereas if I have a negative coefficient, it's going to look more like that, which is going to give me an overall negative slope. Okay, so that's what that means. Positive direction, negative direction. If it's even, then both are going to go positive, or if it's a negative coefficient, they're both going to go negative. But if it's an odd, it has more of a directionality to it. Size, -1 to 1. In other words, this is saying that the absolute value, and I don't know why I just put double. That means something totally different. Come on. There we go. The absolute value of A is less than 1. In other words, it's a fraction, negative or positive, but it's less than 1, right? So it's got that fraction. If this is true, then it's wider. Or another way to look at it is flatter. So actually just or flat. I'm not sure if that's spelled right, but there you go. Okay, now, on the other hand, if the absolute, and again I did it with 2 lines. if the absolute value of A is greater than 1, then it's narrower or taller. Okay, what I mean by that is, again, in a cubic, let's look at a cubic. In a cubic, flatter, instead of these above are taller. Flatter, I mean, it's going to actually end up rotating down like that, right? Because that's very flat. Instead of being up, it rotates it down slowly but surely. That one's also rotating, so let me draw it better than that. Okay. What it's going to do is take a graph that looks like this, and slowly it's going to go flatter and flatter. Okay. Now, on the other hand, it's going to get taller. And if you look at this, for example, in a cubic, this little flat area is almost flat. It has a very low slope. But as you change your A, that almost disappears. Like a very large A, and you're going to get something that does this. There's almost no flat area, and it's really almost vertical. All right, so leading coefficient. Use the leading coefficient test to determine the end behaviors of graphs of polynomial functions. So we have to know degree, and we have to know the leading coefficient. All right, a leading coefficient is the coefficient on the highest degree term. We've already talked about what that was. If the degree is even, then the end behavior is the same both to the left and to the right. If the leading coefficient is less than 0, overall direction is negative. If leading coefficient, that's what we've just been talking about, is positive, then overall direction is positive. Okay. So here we have a cube root and a negative. So it's going to go like this because it has a generally negative directionality. So it's going to have basically a negative directionality. Whereas here I have positive and it's fourth, so it's going to look something like that. Negative and fifth, so it might have, but its overall is negative. Right, here we have a positive and an eighth. So we're going to be 1, 2, 3, 6, 7. There we go. Something like that. All right. Moving on. Analyzing a polynomial. Find and use the real zeros of a polynomial function as sketching aids. But we're going to analyze these polynomials. Given the general form, you're going to factor it. Zeros are from the factored form that equal to 0. Multiplicity is based on repeated zeros. Odd has 1, 3, or 3 copies, or an odd number of copies of a 0, and an even has 2, 4, or 6, etc. copies of a 0. Turns, the number of turns in one of these things is 1, the degree minus 1. That's why my x to the 8th on the previous slide, I did 7 turns. X to the 5 had 4 turns, right? Let's look at those. Okay, 4 turns. 1, 2, 3, 4. So it's 7. 1, 2, 3, 4, 5, 6, 7. 7 turns. Okay. So now we're going to work with some actual equations. Find and use the real zeros. Equation is x squared minus 6x plus 9. So we set it equal to 0, which means we're going to factor this, and we have x, factors of 9 that add to 6. So that's going to be 3, 3. And this negative tells me they're both negative. That means x equals 3. That's a 0. It has a multiplicity of 2 because I have 2 of them. The next one is 3x minus 3. This is going to have one term. It's a quadratic. Here we have a cube. We're going to factor this. Generally, the first thing you try when you have four terms like this, factor by group. So I'm going to kind of group these before I go. I have x dx squared minus 4x plus, whoops, 12. I'm going to root 3. And 2 is root 3. 12. Notice I had to flip the signs because I pulled out a negative that's now sitting between the two parentheses. All right, which is really close. Now I can factor out an x squared, and I can factor out a 4. And now see, they both have x plus 3. I can factor the x plus 3 out. So it's now going to be sitting out front. And what's left is what is left after I factor it out. That's going to be negative 4 and the x squared. That's been factored out. And then here we have x squared minus 4, which comes from the two green terms. Okay, but understand that this can actually factor one more time. I'm not sure why I've got these random colors on here, so I'm going to get rid of them. All right, one more time. Oh, dear me. I hit it with my finger. There we are. Okay. Now the x squared minus 4 is actually a difference of squares, so I have x minus 2 and x plus 2. So I now have 3 zeros, 2 minus 2 and minus 3. Multiplicity, each of them has a multiplicity of 1. And then, what was my other column title here? Terms. This was an x cubed, so I'm going to have 2 terms. All right, let's move on. One more slide. Find an equation given the zeros. Okay, so here I have 2 zeros. Notice, and this is always going to be true, my irrational ones, the ones with the root 3, are conjugates. Irrational, if you remember this from Algebra 2, irrational always have appear in conjugates, as do imaginary. This all comes from our quadratic formula. Remember the plus and minus? That plus and minus the square root of b squared minus 4ac. Remember our quadratic formula was square root of b squared minus 4ac all over 2a. Well, that square root right here with the plus and minus, that's what makes them always come out in conjugates. If it's irrational, I can't simplify it, so it's going to be plus and minus the radical. If it's imaginary, it's still plus and minus the imaginary number. So you're stuck with conjugates for irrational and imaginary. All right, so we're looking at this and saying, okay, we've got factors. Let's say x minus 3 as a factor. We have x minus 2 minus root 3. And we have x minus 2 plus. All right, now we got to FOIL these. Now the easiest is going to be to FOIL the 2 with the irrational portion because those will cancel out. So when I factor this out, right, okay, so now I have x times x squared. This is squared is perfect. Now I have x times minus 2. X times minus 2. And x times root 3. I have my minus 2. I have a minus 2x. can stack it. I have minus 2 times plus I have a minus 2 plus times 3, or I have a minus 2. All right, then I take the root 3. Minus x. I have a plus 2 root 3. And I have a root 3 times root 3 is just 3. That's minus that, so I have a minus 3. Now, if I add these up, I'll see that this x cubed is canceled by negative x cubed. X cubed, cube root of 3, sorry. Those are the same though. Minus 2 cube root 2 root 3 and plus 2 root 3. Those all cancel out. So what I'm really left with would be x minus 3 times x squared minus 4x, right? Because that's minus 4x, and this is going to be plus 1. Now I can factor this one. So what I'm going to do, apologize, I have no idea where the control panel is. There we go. Okay, I apologize. So first the x's, so I have x cubed minus 4x squared plus x. Now the negative 3, so I have negative 3x squared plus 12x minus 3. This comes out x cubed minus 7x squared plus 13, plus 13x minus 3. Yay! Okay, so that gives me my answer. That's the polynomial that if factored would have those factors. All right, so now you're going to go do your in-class practice. And since I'm not going to be coming back on with another video for you, I'm going to go ahead and let you see the answers. But do your work and then compare these to your work. All right? Okay, and we're done.